Hey everybody, I want to give you some overview tips on homework 2 here, and hopefully this will help you complete it efficiently. And what I've done is posted a few examples here on the Moodle site, and these are from last fall, and each example shows you a different way to go about doing this homework. So feel free to look through those, but those are up there, and I can talk more about those in a second. But let me give you just some overview as to what you're going to be doing here. So what you did in homework 1 was carry out all the steps for a simple linear regression and do some basic interpretation and report it. And you will, in a sense, do the exact same thing for homework 2, but now I'm not going to tell you exactly what model to use. And the point of this homework is to get you to test different models in any way you want in order to arrive at what you think is the best model for your data. So this is where it's neat in that you each have different data, because you each are going to have a different model, most likely, when you're done with this assignment. So I like this assignment, and to me, this is the height of the class, is completing this assignment, because this is similar to the full thinking of how you do an analysis and how you might start to talk about it. So for this assignment, you will use the data that you collected before, as long as you are happy with that data. That's why I had you collect all the other variables, like number of bedrooms, number of bathrooms, calculating the age, because now you are going to consider those other variables. So the data is the same, and it's pretty straightforward what you need to do. I just have a lot of words here so that you know exactly to what extent you need to report things. So just introduce your data and the situation like you did in homework 1. You can probably just copy and paste that, pending my comments on your homework 1 introduction. So just feel free to use that again. And then you're going to do the initial scatter plot like I've had you do before, but now you're going to do it for each explanatory variable that we have here. And all these instructions are here. Include your plots, describe each one like you did before. Here's the big shift from the first homework. If you look at your scatter plot and it just doesn't look good to you, if it doesn't look linear, if it looks like maybe some kind of data transformation would be useful, maybe you want to think about an outlier and what to do with it, I'm going to give you that chance right here to talk about that. And if you, for example, if all your scatter plots look fine to you, then great, you can say that and then keep going with the analysis. If you see a problem, if you don't see a good relationship, a good linear relationship, I encourage you to try a transformation of some kind at this point, and then look at that scatter plot again, and then keep going. What most people encounter is that they try to take a logarithmic transformation, either because there's just a little bit of curvature, or because there might be an outlier or two. And there is generally not a great justification for removing outliers with these housing data. So it's often best to just try a logarithmic transformation if you see that there maybe are some outliers from your scatter plot. And that should reduce the impact of the outlier. And then you can go on from there. But point being, just look at whether or not you might do a data transformation and then actually carry it out before you keep going. So that's what this step is about. But again, if you like the way your data look, that's fine. You just defend that point that they look good. You can just argue that they're fine and then keep going. So the third step of this homework is this is the heavy part of the assignment. This is the big thing. And this is where these examples I've put up will be useful because, I mean, doing scatter plots, there's really just one way to show and talk about a scatter plot. There are so many ways to find your best model. So that's why I've given you 2 examples from the last semester to give you some ideas. And as we're learning about ways to select a best model, whether or not we use backward elimination, where we start with all variables and move backwards, or forward selection, where we start with one variable and then add another variable. I don't care how you do it. All I want you to do, as I explain in these steps, is document each model you tried and the process for how you went about testing each model. So for this third part of the homework, when the whole thing is done, just list your final theoretical best model, and then actually list the regression equation that you will get from R. So just list those things once you have found your best model. And then you're going to basically share the story with how you got to this best model. And what you can do, you could just basically talk about the steps. And you say, I started with this model for this reason. And then I looked at the output and I saw this, I saw this, I saw this. And I decided to try this model. And then I saw this, so I decided to try this model. Basically document each model you try, and then I guess what you saw and why you went on to trying another model. And I don't have major requirements for how much you report when you talk about these things. Just share your clear logic for why you went from one model to the next. And this should be, it should be a number of paragraphs. For some people, it could be a few more pages if you're including output in it. It's telling something that I could say, take your story and then reproduce what you did. The important thing is that as you are done with that, and as you get to your final model, I want you to make sure that for your final model, you share each of these things as justification. So the adjusted R-squared, the individual explanatory variable significance, talking about the overall model significance, the VIF, the assumptions, which I'll explain more about in a second. And then this is always important. It's a thing we often forget about. Just your logic, why you think your model makes sense, or why you wanted to include the things you did. Maybe you ended on a model that's just square feet and age, and just take a sentence to explain why that model makes sense, or why that fits in with your idea about why this model makes sense. It's important that the statistics play a role in our model, but also that some logical, theoretical reason also plays a role in our final model. It's important to be thinking about why we're doing what we're doing. So the point about assumptions is that definitely check your assumptions. Here's the thing. If your assumptions are generally well met, or 3 out of the 4 are met, that's fine. Then that's sufficient. That's good enough. If your assumptions are really bad, if they're just things are not normal, if there's really bad non-constant variance, I encourage you to try something. Try a data transformation. Maybe even go back and try a different model, but just try something to try to make those assumptions better met. I don't want you to spend all day trying to make the assumptions perfect. that will mimic a more realistic situation. For this assignment, I just want you, if you can't get those assumptions to be reasonably well met, to just try something and talk about that something. And if you can't get your assumptions looking great, then just talk about that. But at least give it a try to make it work out. And then add that as part of your story. And I guess to help this idea of testing models and finding the best model easier, I think the important thing is to note that there may be many great models and you just have to pick one, and that's a-okay. That's really okay. There's no right answer for this assignment. For any given data set, there is no clear best model necessarily. You may have different justifications. Maybe you think that the adjusted R squared is the most important thing in your model, and that's fine. You can definitely do that. Another person may say, well, I think it's really important to account for size, to account for age, and to account for at least bedrooms or bathrooms. And maybe not everything is significant, but I think theoretically that should be included. That's fine too. This goes back to, I want you to come up with something and defend it and give good reasons for your defense. And those reasons can change from person to person. This is the fuzzy nature of statistics, and I want you to experience some of this so that you get this idea of, yeah, there's some wiggle room here, but I'm going to pick this model and stick by it and have these reasons for it. So, yeah, you can spend a couple of pages on this or so. And again, look at these examples for how you can go about doing this. These examples are not the only way to do this. There are so many ways to do it, but hopefully that will give you some inspiration. Whoops. And great. And the last thing to do, naturally, is to interpret what your variables mean. So once it's all said and done with your final model, just go in and one variable at a time, interpret it as best you can. And this either means, a slope coefficient interpretation, if you can do that. The trick is if we have interactions or if we have a data transformation, our interpretations will change a little bit. So this is why I've had you practice interpreting things with interactions, or thinking about models where it's not just a straightforward one variable, two variable, and nothing else. So you're going to interpret each explanatory variable and interpret, if you can, the coefficient on it. But again, if you have interactions or more complicated models, that might change a little bit, and you might not be able to say anything very specific. This is why I've made the guides I've made, so that you can have examples and things to rely on to figure out how to best interpret. And of course, please send me questions if you're not sure. I'm very happy to guide and help and make sure you get the best chance to explain your thinking here. But that's all there is to it. So high-level summary, introduce your data and the situation, do your initial scatter plots, comment on them, consider any transformations if you need to, find your best model, tell your story, provide your justification, and then write out your best model, write out it theoretically, write it out with the numbers in it, and then explain what each of those explanatory variables mean to really give this whole situation meaning so that we can understand what might go into the housing price for each of your data sets. So that's my explanation for that. Again, send me questions, and good luck with this, and I hope it goes well. All right, thank you.